Section 8.3 is on graphing reciprocal functions. So basically, this chapter we've been working with variables in the denominator. And so now we're going to be graphing simple ones with variables in the denominator, basically a linear term in the denominator, or a linear expression. And so this is the parent function of a reciprocal function. You have y equals 1 over x, or f of x equals 1 over x. That's the most simplest reciprocal function there is. So let's go through this one and talk about what happens and get an idea of where we're at with this type of a problem. Okay, when you look at this and you put in a value for x, basically that value is the reciprocal of what it's going to be. So in other words, you put x in, y is the reciprocal of x. And so when you look at a table, and if I start my table at 0, if I put 0 in, that's undefined, because you cannot have the reciprocal of 0. 1 over 0 is undefined. If I put in negative 1/4 in, that becomes negative 4. Negative 1/2 in, that becomes negative 2. Negative 1 is still negative 1. Negative 2 is negative 1/2. And negative 3 is negative 1/3. So, like I said, whatever you put in for x, it becomes the reciprocal. Likewise, on the positive side, it's going to be the same, just positive. And we should be able to graph those points. Okay, so if I graph these points, 0 is undefined. That is considered a vertical asymptote. X equals 0. You have to write the asymptotes as an equation, x equals, because it is an imaginary line that x cannot be. Okay? And now I'm going to put in these points. If you put in these points, at 1/4 you get 4, 1/2 you get 2, 1 you get 1, 2 you get 1/2, 3 you get 1/3. What happens is, because x can't be 0, as you go this way, the smaller x gets, the larger y gets. As you go this direction, the smaller x gets, the larger x gets, the smaller y gets. Likewise, on this other side, here we're at 1, 1, or 1, negative 1, I should say. So it looks like this. Okay, and this graph is called a hyperbola. Now, let's look at these other things. If you notice, as x gets larger,